Welcome back to Learn Civil Easy. This is the detailed solution video for our Module 3 practice paper on design parameters of sewerage. We have 15 MCQs and 2 numericals to walk through. Let us begin. Question 1. As per the CPHEEO manual, the design period for trunk and outfall sewers, the correct answer is C, 30 to 40 years. Trunk sewers are buried deep and very hard to replace, so we designed them for the longest horizon. By contrast, pumps and motors last only 10 to 15 years and treatment plant units 15 to 25 years. Question 2. Best forecasting method for a rapidly growing industrial city. The correct answer is B, geometric increase method. The geometric method assumes a constant percentage rate of growth which fits a fast-growing economy. The arithmetic method underestimates and the logistic method is meant for cities approaching saturation. Question 3. The return factor K typical range, the correct answer is C, 0.70 to 0.85. Not all the supplied water reaches the sewer. Some is lost to evaporation, gardens, and leaks. So sewage flow equals roughly 70 to 85% of the water supplied. The standard design value is 0.80. Question 4. Harman's formula for peak factor. The correct answer is A, PF equals 1 plus 14 divided by the bracket 4 plus square root of P. P is in thousands. This is the most used formula in Indian sewerage practice. Babbitt's 5 over P to the 0.2 is option B, but not the standard. Question 5. Harman's peak factor for population 1 lakh, that is P equals 100,000. The correct answer is B, 2.0. Plug in 1 plus 14 over 4 plus square root of 100. Square root of 100 is 10. So 1 plus 14 over 14 equals 1 plus 1 equals 2.0. Memorize this. It appears in GATE almost every year. Question 6. Minimum self-cleansing velocity in Indian practice. The correct answer is B, 0.45 to 0.60 meters per second. This velocity keeps suspended solids in motion and prevents siltation. Below 0.45, the sewer chokes and produces hydrogen sulfide gas. Above 3 meters per second, it scours. Question 7. Manning's roughness for new RCC sewer pipes. The correct answer is B, 0.011 to 0.013. Standard design value is 0.013. Old or rough pipes go up to 0.015. HDPE and PVC are even smoother at 0.009 to 0.011. Question 8. Hydraulic radius for a circular sewer running full. The correct answer is C, D over 4. Area is pi d squared by 4. Perimeter is pi d. So R equals A by P equals D by 4. The neat result is that R is the same whether the sewer runs full or half full. Diameter cancels. Question 9. Maximum non-scouring velocity for vitrified clay. The correct answer is C, 2.5 to 3.0 meters per second. Vitrified clay is moderately hard. Cast iron tolerates higher, around 3.5 to 4.5. Brick masonry tolerates lower, around 2.4. Above the limit, the inner surface erodes. Question 10. Time of concentration in storm water design. The correct answer is A, Tc equals Te plus Tf. Inlet time Te is the overland flow to the nearest inlet, typically 5 to 30 minutes. Flow time Tf is the time inside the sewer equal to length divided by velocity. They add, they do not multiply. Question 11. Rational method runoff coefficient C for asphalt or concrete pavement. The correct answer is C, 0.70 to 0.90. Pavement is nearly impervious, so most rainfall becomes runoff. Lawns and parks are at the other end with C as low as 0.05. Question 12. CPHEEO design period for pumps and motors. The correct answer is B, 10 to 15 years. Mechanical equipment ages much faster than civil works. Pump station civil works last 30 years, but the pumps inside need replacement every 10 to 15 years. Question 13. Logistic curve method best suited for? The correct answer is C, a mature city approaching saturation. The logistic curve is an S shape, slow start, fast middle, then a flat saturation. Verhulst proposed it. It needs long historical data, so it does not suit small villages or new towns. Question 14. Per capita water demand for cities with full flushing and sewerage. The correct answer is C, 150 to 200 LPCD. Towns without flushing need only 70 to 100. Metropolitan cities go up to 270. The CPHEEO ladder is worth memorizing. Question 15. Hourly variation peaks in domestic sewage. The correct answer is B, 6 to 9 am and 6 to 9 pm. Bathing, cooking and toilet use peak in the morning and evening. The night minimum is around 2 to 4 am. Sewer must remain self-cleansing even at this minimum flow. Numerical 1. Peak factor by Harmon's formula. Population 50,000, average DWF 6,000 cubic meters per day. Step 1. Square root of 50 is 7.07. Step 2. PF equals 1 plus 14 over 4 plus 7.07 equals 1 plus 14 over 11.07 equals 2.27. Step 3. Peak flow Q peak equals 2.27 times 6,000 equals 13,620 cubic meters per day, or about 0.158 cubic meters per second. Numerical 2. Rational method storm discharge. Catchment 12 hectares, runoff coefficient 0.55, rainfall intensity 60 millimeters per hour. Apply Q equals 1 over 360 times C times I times A, with I in imp per hour and A in hectares. So Q equals 0.55 times 60 times 12 divided by 360 equals 396 over 360 equals 1.n cubic meters per second. That is the design storm discharge. That completes all 17 solutions. To recap, design periods follow the CPHEEO ladder, peak factor uses Harmon's formula, velocity stays between 0.45 and 3 meters per second, and storm flow uses the rational method. The next lecture in this series is operation and maintenance of sewers, coming up next on the channel. If this video helped, please like, share and subscribe. Thank you and see you in the next one.